In this video, we're going to be going over the second part of lesson 3.3 on proving lines parallel. If you haven't already completed the 3.3 day 1 notes, you should go back and watch that video first. Here, we're going to pick up on example 3 and continue with our learning target. I can use angles formed by a transversal to prove lines are parallel. Here, we want to find the value of x for which A is parallel to B. The first thing you should do when you solve a problem like this is decide on what type of angles you have. Notice in the picture here that the two angles that are marked are same side interior. And then if we want the lines to be parallel, we know that same side interior angles need to be supplementary, meaning they have to add to 180. That's the converse of the same side interior angles theorem. We can make an equation for supplementary by adding the two angles together. That's 7x minus 8 plus 62 equals 180. And now let's do the algebra. Let's combine our like terms. Negative 8 plus 62 is 54. So 7x plus 54 equals 180. Now let's subtract 54 on each side to get the 7x alone. That gives us 7x equals 126. And now we can divide by 7. And when we put that in the calculator, it is exactly 18. So the value of x for which A is parallel to B is equal to 18. Here we don't need to find the measures of the angles. We just needed to find x equal 18. If you wanted to, you could double check and plug it back in to the 7x minus 8. So I could take 7 times 18, subtract 8, and that is 118, which, if we verify, 62 plus 118 does add to 180. Here's a try now example. Once again, we want to find the value of x for which the two lines, U and V, are parallel. Before we make our equation, we should always look and see what type of angle pair do we have. Notice that these two angles are corresponding angles, and if we want our lines to be parallel, corresponding angles need to be congruent. So this time, they have to equal each other. For the equation, we would go 8x minus 4 equals 6x plus 14. And now we can just do our algebra. Let's move all the x's to one side. I'm going to subtract 6x on each side. So we have 2x minus 4 equals 14. And then we can add 4 on each side to get 2x equals 18. Divide by 2. And we get our answer, x equal 9. With the red arrows. For our final example, and then I'm also going to add a marking proof for angle 1, some of the theorems. Congruent. So here we're given angle 3. Okay, for our proof, we always start at our given. And you can list the givens all in one step, or you can list them separately. This time, I'm going to actually list the givens separately, so I'm going to put L parallel to M as my first line. Given. And then given that L and M are parallel, notice that angle 1 and angle 2 are corresponding angles with L and M. So we know that angle 1 is congruent to angle 2 by the corresponding angles postulate. Now I'm going to use the second given. For the second given, for number 3, we are also given that angle 1 is congruent to angle 3. And if we combine step 2 and step 3 here, so we put these two lines together, two angles that are congruent to the same angle are congruent to each other. See, there's this match right here, right? Angle 1 is congruent to 2, and angle 1 is congruent to 3. So if we put those together with our transitive property, for line 4, we can say angle 2 is congruent to angle 3 by the transitive property of congruence. Now, let's go ahead and see what we can do next. So now that we have a pair of transitive, see how those 2 and 3 are alternate exterior angles with P and Q? Well, if we have a pair of alternate exterior angles that are congruent, we know that P must be parallel to R, or R must be parallel to P. So R parallel to P by, and since these two angles are alternate exterior angles, we would use the converse of the alternate exterior angles theorem. Let's try one more example here. This one is a proof as well. And here we're given that angle 1 is congruent to angle 4. Let's mark that in our picture. 1 is congruent to 4. And then we're also given that 3 and 4 are supplementary. This one, I'm going to start off by listing both givens on the same line. So if I wanted to split these up, I could, like I did in the last one, but I'm going to put them on the same line. 1 congruent to 3, and angle 3 and angle 4 are supplementary. So that is given. Next, we're going to want to use the definition of supplementary, and we're going to want to use a substitution. So rather than congruent angles, let's switch angle 1 congruent to angle 4 to the measure of angle 1 is equal to the measure of angle 4 by definition of congruent angles. All right. Next, let's use the definition of supplementary. So we're told that 3 and 4 are supplementary. By definition, we can say the measure of angle 3 plus the measure of angle 4 equals 180. By definition of supplementary. Okay. So my goal is to end up with L parallel to M, and right now I don't have enough information. Like, I would be able to say that L was parallel to N right now because 1 and 4 are corresponding. Let's see if we can kind of bridge the gap, because eventually I want to have these two lines right here parallel. We just don't have quite enough information yet. But notice that angle 3 right here has a vertical angle, angle 2. So for the next line, for line 4, I'm going to say that the measure of angle 2 is equal to the measure of angle 3 by the vertical angles theorem. Vertical angles are congruent, so angle 1 or angle 2 and angle 3 are equal measure. Okay, so now we should be able to do some substitution here. Because in my expression right here for angle 3, I could replace the angle 3 with angle 2. And we could also make a second replacement if we look here. Angle 4 is equal to angle 1. So let's go ahead and make a substitution here where I'm going to trade angle 3 for angle 2. So measure of angle 2 plus, and I'm going to change angle 4 to angle 1 equals 180. And there we did substitution. So I substituted from this step and step 4. And I substituted that into step 3. So I made that trade for the angle 3, I traded with angle 2 from step 4. And angle 4, I traded with angle 1 from step 2, so that we have angle 2 plus angle 1 equals 180. Well, now let's look at angle 2 and angle 1. These two angles are same side interior angles. And we now have just shown that the same side interior angles are supplementary. So I'm going to do my next line of my proof is going to be angle 2 and angle 1 are supplementary. And that's the definition of supplementary. And now, finally, 2 and 3, let's see how they are same side interior with L and M. So we can conclude our proof with line 7. L is parallel to M by converse of same side interior angles theorem. This proof here is definitely more complicated than the one you're going to see on your CYU. Your CYU will be a fill-in-the-blank style proof. Same thing on any assessments that we have for this chapter. We're going to have it be more fill-in-the-blank style proof. I still think this is a good problem, but it's just more advanced than one that I would expect you to do by yourself. That's it for lesson 3.3, day 2. Thanks for watching, and good luck as you practice proving lines are parallel. Bye.